Hello, and thank you all for joining us for today's product briefing. I'm Alex Schuker, CTO at Draitech UK and Ireland, and joining me is your presenter for today, Amy Hood, Product Specialist. The topic for today's product briefing is our first Wi-Fi 6 access point, the Vigra AP 960C. We're really excited to be able to share with you the details of it today and to talk about Wi-Fi 6 and some of the benefits you'll get from it. Before I hand over to Amy, I'd like to just give you a quick overview of the Weber interface.
Thanks, Alex. Hi everyone, I'm Amy Hood, and today I'll be introducing Draitech's first Wi-Fi 6 access point, the Vigra AP 960C. Wi-Fi 6 brings in many new features that are well suited to businesses and high traffic environments, as well as home users. In today's presentation, I'll start by introducing the AP 960C. Then I'll detail some of the benefits and features of the new Wi-Fi 6 standard. Finally, I'll talk about some other interesting Vigra AP features and demonstrate the new AP in action. Now to introduce the first of Draitech's Wi-Fi 6 products. The Vigra AP 960C is a ceiling access point. It has two spatial streams with both 2.4 and 5 GHz Wi-Fi 6 radios, giving 600 megs link rate on 2.4 and 1200 megs on the 5 GHz band for AX1800 performance. It features the latest Wi-Fi 6 technologies, which have the potential to significantly increase client capacity, serve more demanding networks, and address some of the limitations of Wi-Fi as a whole. Let's look at the design of the access point. It's been updated to easily blend in with any environment with its understated matte finish. The wireless activity light can be turned off or scheduled as well. Looking at the back of the AP, the Gigabit Ethernet port can also power the access point, with regular power over Ethernet for use with any standard PoE switch or injector, which is ideal for installing the AP in locations where power isn't readily available. And there's a DC plug for powering it in a fully wireless environment. This new AP is ceiling or wall mountable, with fittings included for both solid surfaces and suspended ceilings, including a twist-on mounting plate and T-rail clips. If you're upgrading from previous Draitech ceiling access points like the AP 910C or AP 912C, the mounting plate is the same, so it's easy to upgrade. The Vigra AP has three modes of operation to suit lots of applications. In access point mode, it can provide up to 8 wireless networks, 4 per band, with a cabled uplink. Range extender mode allows the AP to extend coverage of any wireless network by connecting to and rebroadcasting that network to boost its range. Lastly, Mesh connects up to 8 access points as a fully wireless mesh group. The AP 960C can be used as a mesh node or as the wired mesh route, which provides internet access and controls the group. So if the wireless password is changed on the mesh route, this propagates out to each mesh AP. Wi-Fi 6 is a very ambitious step forward when compared with previous standards. I've broken down what I think are the best features of Wi-Fi 6 into these categories. Before I go into the details of Wi-Fi 6, I'd like to cover some of the history. Wireless networking has now been in use for over 20 years, and in this time it's transformed how we use computers and technology, freeing us from fixed cable network connections. More and more devices are now connected, and usage is still increasing with video conferencing and streaming much more popular. Wi-Fi has evolved to keep up, using more advanced encoding, increased bandwidth, and using more spatial streams or antennas to further boost throughput, otherwise known as MIMO, short for multiple in, multiple out. Wi-Fi 6, or 802.11ax, is the 6th generation standard. The key improvements of Wi-Fi 6 are not so much bigger numbers and faster headline speeds, although it does achieve that. Instead, improvements are focused on better efficiency, with a resulting speed boost for all clients and increased capacity. Wireless has a fundamental limitation in that to communicate successfully, it's essential that only one device is transmitting at a time. One way to think of this is as a single-lane road. Each vehicle waits in the queue. This means that wireless can give excellent speeds to a single user, but with more users, speeds will rapidly drop for everyone. Small packets that need to arrive more promptly, for instance, online gaming or voice over IP packets, can also get stuck in the queue, potentially causing higher latency and packet loss. Wi-Fi 5 or 11AC Wave 2 worked to improve this with multi-user MIMO to send data to clients with each antenna or spatial stream. With two streams, you could send to two users at once, downstream, where the AP sends data to clients. Wi-Fi 6 improves MU-MIMO to work in both directions potentially. However, in many real-world environments, it's not as beneficial as a key new technology of Wi-Fi 6 called OFDMA, which I'd like to cover now in more detail. OFDMA stands for Orthogonal Frequency Division Multiple Access, which is just as simple as it sounds. Essentially, Wi-Fi 6 uses wireless in a different way than previous standards, which use wireless channels as a single block to send and receive data. OFDMA splits up the channel's bandwidth into many smaller channels. This is new to 802.11 wireless, but it's been used to great effect in 4G LTE networks to handle many users communicating at once. These smaller channels are referred to as resource units. 20 MHz channels have 9 units and 80 MHz channels have 37 to allocate when sending data, meaning that potentially an access point could send data to 37 users at once instead of just 1 or 2. In effect, one access point changes from a single-lane road to a multi-lane motorway, with the access point directing traffic for peak efficiency. Resource units are allocated as clients need them. So if one user is watching a 4K video and another has a voice call in progress, the AP will assign resources to them and send to both clients at once. Small packets like voice data are assigned less, while streaming videos are allocated more. The end result is more clients receiving data more frequently, giving lower latency and more overall data sent. It works in the other direction too. Clients request resources and the AP assigns them. Then multiple clients can send data to the AP at the same time. It's worth mentioning, however, that this does require Wi-Fi 6 clients to get the full benefits in performance. But in mixed environments, newer clients can still benefit and older clients can still communicate at their best speed. In addition to handling more users, Wi-Fi 6 improves a number of other common wireless issues that we all experience. If you're installing a network spanning multiple access points, assigning channels to each one is often difficult. If there's interference from neighboring networks or overlapping APs, speeds can drop while waiting for a cleared channel to send data. BSS coloring works to improve that by adding a unique identifier to wireless traffic beyond just wireless channels. The benefit is that when devices check whether the channel is clear to send and they detect traffic, they can check whether A, does the BSS color match my network? And B, is it loud enough that it would interfere with my communication? If the BSS color isn't matching and the signal is far away, the devices can go ahead and transmit. Without this, any traffic detected on the channel would cause clients to pause, giving lower speeds and more interruptions. This means that Wi-Fi 6 installations can more safely overlap and communication is less affected by neighboring networks, giving better performance. Another interesting facet of Wi-Fi 6 is that it brings these features to both wireless bands, while the previous 11AC standard only improved 5 GHz communication. Although the 2.4 GHz band is comparatively small, it can pass through objects, such as walls, more easily than higher frequencies. With the other improvements of Wi-Fi 6, 2.4 GHz performance is significantly better, giving more overall capacity to the AP and potentially better range along with that. Then there's WPA3 security. Building on WPA2 from 2004, it enhances encryption for enterprise users and adds a new handshake process, which makes it possible for an AP to detect and shut down brute force password guessing attacks. Perfect forward secrecy means any data captured can't be read in future by deciphering the encryption key. And there's opportunistic wireless encryption, which isn't supported by all devices yet, but potentially it means you can have an open wireless network, great for hotspot wireless, which, instead of being completely insecure, encrypts each client's connection separately in the background, so eavesdropping from outside or between clients isn't possible. The last feature I'd like to mention is target wake time, which improves scheduling for wireless clients. This potentially lowers power usage and increases battery life for any portable devices. Instead of checking in periodically at fixed intervals to stay connected, clients arrange when they're next to be available to talk, checking in at the time they've arranged, so they remain connected and use less power to do so. Moving on from the features of Wi-Fi 6, Dratex Vigor APs have a number of other great features to make installation and management easier. I'll start with Dratex Mesh feature. With a mesh network, instead of manually setting up wireless links between access points, which can be both laborious and complex, Vigor APs autonomously arrange connections amongst themselves for an optimal path to the Mesh Route AP or router. To set this up, we can use the Dratex Wireless app to scan the QR code on a new AP. We set this up as a mesh route and select nearby APs to add into the mesh. This then configures itself in the background and can be up and running within minutes. Once the mesh is in place, APs are configured as a group, so changing the wireless password on the route propagates to all the other APs. If a mesh link is disconnected, for instance an AP is unplugged, mesh nodes will connect to the next best link and resume service without interruption. When that link comes back, mesh nodes can rearrange to optimize their path back to the mesh route. For businesses and home users that need multiple wireless networks without cabling, Dratex Wireless Mesh supports VLANs for multi-SSIDs over mesh, which opens up the possibility of guest networks and more with a purely wireless network. Dratex networks have the option of hotspot wireless provided through the router. This captive portal system lets you use the router to show a branded landing page with any connected Vigor AP access points able to show it. Individual websites like company web pages can be allowed in a walled garden or whitelist, and access to the larger internet can be permitted in a few different ways. Users can simply click through, acknowledging terms and conditions, or access can be granted with PIN code authentication, which users can receive via email or text message or social media. The Vigor AP 960C now features its own captive portal facility for networks without a Dratex router. This lets you show branding and terms and conditions for your wireless network, and it can potentially integrate with radius-based portal services like the Purple Wi-Fi platform. Mobile device management is another powerful feature on Dratex Vigor APs that's further improved with the 960C. With mobile device management, the AP can identify the OS and device type of connected clients, with the option to designate specified wireless networks to accept certain device types only. For instance, if we want a wireless network that only has Windows and Mac desktops and laptops connected, the Vigor AP can stop devices like tablets from connecting. Beyond that, in the AP's web interface, we can see who's connected, what type of device they're using, and how much data they've used in the session. Potentially, you can easily locate, then temporarily disconnect or permanently block abusive wireless clients. If you're moving around between access points, a common problem with wireless devices like phones and tablets is that they'll often try to stay connected to faraway access points, even when they've moved into range of a closer AP, effectively sticky clients. Draitec have an easy-to-deploy system called AP-assisted roaming to resolve this, which works regardless of a client's supported roaming protocols. With AP-assisted roaming, Draitec Vigor APs communicate each client's signal strength to other nearby APs, which allows a Vigor AP to disassociate clients if they're aware that there's another Vigor AP available for that now distant client. By doing this, clients are only moved over if there's a better signal nearby. That client can then connect to its nearest AP with minimal disruption and have a better wireless experience. This feature isn't just for Vigor APs. Draitec routers with wireless can also assist in this way. Draitec offer multiple management options for wireless. Manage up to 8 APs as a group with mesh, or we can auto-provision access points as they're connected with AP profiles set up on a Draitec Vigor router or access point potentially. To manage a large single site, the free Vigor Connect software manages up to 100 APs, with the advantage of being able to schedule maintenance like firmware updates to take place overnight. And new to the Vigor AP 960C is the ability to auto-provision and manage Vigor APs from a designated controller AP without a Draitec router on site. With this, we simply set up one access point as a root AP, then select access points for it to manage. From there, we can use config sync to provision settings to the group. For multi-site management, an unlimited number of APs can be managed with the Vigor ACS Cloud Management Platform, which can manage all your Draitec routers and switches as well. Vigor ACS gives a central overview of many networks or sites with summaries of alarms, usage, and users connected. You can provision access points across multiple sites and schedule maintenance tasks to occur overnight. And it can be used to set up floor plans, which can be useful to record access point locations for future reference or troubleshooting. As well as record client connection times and usage per user. With the Vigor ACS Cloud Premium or self-hosted, Vigor ACS can also generate reports for you using this data. So that sums up some of the new and existing features with this new Vigor AP. Draitec offer a wide selection of Vigor AP access points to suit any application, with weatherproof outdoor access points and indoor APs with wall and ceiling mounted designs. Looking at how the new Vigor AP 960C fits into the Vigor AP range, it's going to work well with existing networks of Vigor APs, with all features such as AP-assisted roaming still being compatible, with the exception of Wi-Fi 6 specific features. Bear with me for a moment while I switch screens so that we can have a look at the web interface of a live Vigor AP 960C that I have with me. Okay, so here's the AP 960C's web interface, and it stayed logged in. So to start with, I'd like to show the dashboard. So this gives a summary of everything on the access point, such as usage, the channel status, and whether that channel is particularly busy. Say if there's interference, it can show it here. Additionally, we can also see whether it's connected to the internet with this gateway indicator here, green if it's working, red if it's not. And ACS is indicated here as well. In this case, this AP doesn't have ACS set up on it, so this will of course be red. You can also see the wireless SSID here, and you can edit those potentially. You'll notice this is defaulting to DRATEC and then these numbers. This is the last half of the AP's MAC address, so each AP has a unique SSID out of the box, which aids in setting it up because you can identify which is which. Okay, so moving on to, oh, in fact, if I scroll down, so scrolling down, we can also see who's connected and how it's being used. So if there are clients that are heavily using the AP, we see them in a list at the top here. So we can see which clients are the busiest, along with a graph over time showing the data usage and clients connected. Right, so moving on to AP management. So I mentioned that the AP960 can manage other APs, and that includes older APs like the 910C, for instance. So to do that, I just enable the Manage Other APs option, so enable Root AP, discover some nodes which locates other APs on the network, and then we select all the APs that we want to manage. And the way this works is, if you've set up mesh on DRATEC Viger APs, then the provisioning is similar to that. So config sync is used to push settings from the root AP out to the client APs. And we can see APs that are managed in here. Currently it's managing no APs. And you can see it can manage up to 30 different access points. Okay, so moving on, building on from the station list or list of clients that I showed on the dashboard, we've got mobile device management, which summarizes all the wireless clients from both wireless bands, and we can see the usage or activity of each client. So in a list here, potentially, as I mentioned, if one of these clients is disruptive, you can deauth to disconnect them or block them. And if we click on a client, we can see the current status and additional details for the AP with traffic graphs for an individual user. So you can see things like link rate over time and data transmitted over time for just one user. Okay, one other thing I'd like to mention is there is a feature on Viger APs called Interference Monitor, which I find is a very helpful tool for determining the best channel to use in an environment. So to use the Interference Monitor, we just click refresh. So we scan the 2.4 gig band. And we can see here that channels 10 and 3 are about the clearest. So probably with my environment, it's best to use channel 11 because that's the clearest whole channel. So because this is a dual band AP, another thing I'd like to show is band steering, which is used to push clients from the 2.4 gig band onto the faster 5 gig band. And you'll see here there's some new options. So it can do more checks to ensure it's only moving clients over where that's going to work well. And the way this works is it temporarily hides the 2.4 gig band when a client tries to connect, so that that client will then connect to the 5 gigahertz band. And I mentioned earlier about the AP-assisted roaming feature. And just to show what's involved with setting that up, all we need to do is enable, so on AP-assisted roaming, we set minimum RSI on the AP, and that's it. That's all we need to do. So this needs to be set on each of the APs or routers that you're doing this with, but that's the only setting that needs to be changed. Now, the last thing I'd like to show is the wireless settings. So you can see here, if you're logged into the AP's management panel with the admin password, then you can check the wireless password just by clicking on it. So we can see that password there. And if we want to change the password, I'm not sure if it shows the strength one on this one actually. Okay, so the WPA3 mode, you'll notice as well there is mixed WPA3 and WPA2 personal. That means that WPA2 clients that don't support WPA3 can still connect. And you can see there's a good number of security options available, including OWE with current firmware. Okay, right, that finishes the live demo. So for pricing and availability of this new Vigra AP, the 960C will be available from the 3rd of February with a suggested retail price of $199. If you have any additional questions about features or pricing, please contact your Dratec reseller. To summarize the Vigra AP 960C, it's an AX1800 class Wi-Fi 6 ceiling access point, and it has a new look to blend in with any environment it's installed in. Wi-Fi 6 brings in many improvements to build on existing wireless standards, with the potential for much higher capacity, better handling of interference, and uplifting performance of both Wi-Fi bands. So that concludes today's introduction to Dratec's Wi-Fi 6 solutions. Now I'll hand back over to Alex for your questions and answers.
Hi, Amy. Thank you very much for that run through. That's very interesting. It's good to learn some more stuff about the Wi-Fi 6 technologies and how it fits in and the benefits it gives us. We've had lots of questions during the presentation, so thank you everyone for putting in your questions. We hopefully have answered most of them directly on the text, so you should get answers on there. If there happens to be any that we don't do or aren't able to get around to answer, we normally will send an email to you afterwards with an answer to your question. But in the meantime, while you continue, you're welcome to continue asking questions. We can still answer those directly. But in the meantime, let's cover a few of the questions over the audio now. So first question, Amy, is about the shape of the propagation of the wireless signal. This is actually quite a common question we often get. Kind of the question is, what sort of shape does it propagate and what does it look like?
Okay, so the antennas on the 960C are designed to be omnidirectional, so they don't focus on one specific direction. You can think of the shape as something like a donut. Essentially, it propagates outwards and downwards. So an alternative aerial type is unidirectional, which is more of a cone shape and more suited for site-to-site links or covering an area in a specific direction, like a car park. And just for an example of that, the Vigra AP 918 RPD has a directional aerial, but most other Dratec products are omnidirectional. And if you'd like to learn more about wireless antenna propagation, we've got an article on the website, which we'll include in the comments.
Yeah, I've just added that on, so if you look in the comments, you should see that, everyone. Thank you very much, Amy. So next question is about the mesh compatibility. So is the Vigra AP 960C mesh compatible with other Dratec units, or does it have to be used with another 960C?
Okay, so for best performance, yes, you would use it with a 960C, but it is compatible with other Dratec APs, but it would be using the 802.11ac standard of performance instead of 11ax.
Okay, that's great, thank you. And what is the recommended number of, I mean, keeping on mesh, is there a follow-up question about what's the recommended number of maximum hops when you're going from one AP to another AP in mesh without a wire?
Okay, so with mesh, you can have sort of 8 APs, but you can have multiple branches. And the maximum that you can have of each of these branches is 3 hops. So that's one AP transmitting to AP2, transmitting to AP3. But we'd recommend, where possible, to reduce the number of hops, because the more hops you have, the less maximum speed the client would see, because there'd be more time required for retransmission at each point.
Okay, thank you very much. So, a question here is touching on some of the management capabilities. You talked about some of the stuff with cloud management where it can be managed by Vigor ACS remotely. The question here is about what is the cost per node for this. So I can just quickly give an answer on that. So the cost per node starts at around £6 per year, but their price breaks dependent on the number of devices you have. So if you want any more details on that, just get in touch. Email info@dratec.co.uk, and there's also a kind of trial that you can use on that as well. That's just the cloud version and the self-hosted version. The other versions that Amy talked about, the kind of standalone one that doesn't have any costs itself. The Vigor Connect standalone version doesn't have any licensing costs. Right. Now a question about WPA3. The question is, what other products in the Dratec range have support for WPA3 instead, in addition to the 960C?
Okay, so WPA3 support has been added in firmware to a good number of APs and routers where possible. So, for example, the Vigor 2927AC has WPA3. The Vigor AP903 also has WPA3, and the 912C, 918R, 920R, and 1000C. If you'd like to see a full listing, we've got a WPA3 support list on the knowledge base and WPA3 wireless security from the front page of the website.
Oh, I can paste a link to that to the audience.
Yeah, that'd be good. Thanks.
If I can find that, I'll do that in a moment. In the meantime, let's look at another question. Will there be any other Wi-Fi 6 products that will be releasing in the range? Which I guess I can possibly answer. Actually, the answer is yes, there will be some more. I mean, the current products we've got, like the Vigor AP1000, the 903, those are still very much current products, and we'll be continuing to sell them. But we will be adding more Wi-Fi 6 onto the range later this year, and also there will be some router Wi-Fi 6 products as well. So once we've got some news on that, we'll be announcing it. At the moment, it's because of the kind of shortages kind of globally, it's difficult to exactly predict what release dates we'll have on those. But as soon as we've got anything confirmed, we'll be sharing that information with you. So another question here is about Wi-Fi 6 and existing products. Will any of the existing products be able to have a firmware update to add support for Wi-Fi 6?
Okay, so the hardware of an access point or a router is very specific to the generation. So unfortunately, it's not possible to just upgrade firmware to support Wi-Fi 6. It requires some very different hardware for Wi-Fi 6's scheduling to work.
Okay, so it's not possible for just a firmware update to update an existing product. And a related question is about the 5 gigahertz frequency. So someone noticed that the 2.4, the Wi-Fi 6 is running the Wi-Fi 6 on both the 2.4 and the 5 gigahertz speeds. And the question is, are these the same frequency ranges as is used by Wi-Fi 5? So in the 2.4 and the 5 gig ranges, do they share the same frequencies?
Yes, they do share the same frequencies. But with Wi-Fi 6 communication, it is a very different way of communicating. So with Wi-Fi 6 clients, the full benefits, as I mentioned, are only realized with Wi-Fi 6 APs and Wi-Fi 6 clients. But then that does give a really good boost to capacity.
Okay, yeah, and I think we've seen in some of our testing when we've done kind of some of the testing of the throughputs comparing Wi-Fi 6 to Wi-Fi 5, that it's in crowded environments quite a nice boost to the performance that we've seen. So that's quite promising to hear and to see, and I think it should result in some good results for people in their deployments. Right, so let me see if there's any other questions here. The question about roaming. Will the AP-assisted roaming work with other models? For example, would it work with I think the example here is with the 910C and the 960C, or would AP-assisted roaming work in that scenario?
Yes, it would. Because there's not, because it's not reliant on particular 802.11 like roaming standards. It moves clients as it detects there's a better signal. The signaling in the background that is compatible between all the different Vigor APs that support it.
Okay, good. So I think what you were talking about there is that it's the AP that makes the decision to kind of nudge the client to go to a different access point if it detects that it's too far away. What we find is a term called sticky that often some clients, it seems to vary from device to device, can be quite sticky and really want to keep connected to the existing access point that they're connected to for as long as possible. And what the AP-assisted roaming does is it kind of, for the benefit of the client, tells it to go to a different access point that's probably closer. So that we find it works quite nicely and is compatible across different models. And now question here about how many connections the 960C can handle. Kind of what's the number of clients that would kind of typically be recommended for an installation of the 960C?
Okay, so the number of clients per each of the wireless radios is, I believe, 128 as the maximum. Although with lots of clients requesting data at once, especially in a mixed environment, that capacity could be a fair bit less. I mean, with Wi-Fi 6, as I mentioned, OFDMA lets you communicate with 37 different well, potentially 37 different devices at once on each band. So maybe 80 busy clients with Wi-Fi 6, and I would say around 50 clients if it's a busy environment with mixed clients. Okay. But yeah, I tend to err on the side of caution. So if it's an environment where clients aren't so busy, then you could easily just go up to the maximum of its wireless client limits of 256 per AP.
Okay, thank you. And that's simultaneous, because you can have much more than that over a day, because if someone connects and then goes away, then that doesn't stop someone else from connecting. It's the limits that we're talking about there are just the number that are simultaneously in the same vicinity of the access point at any one time. Right, thank you very much. I think that's a good point to close it there on the questions. Thank you very much, everyone, for all your questions and for attending today. We hope you found the presentation useful, and do get in touch if you've got any more questions with us. And we will be sending kind of follow-up details of how to watch the webinar again if you want to pass it to any colleagues, or if you were interrupted at any point and want to re-watch the presentation. So thank you very much for attending, and thank you very much, Amy, for your presentation.
Thanks.